ready for chapter 13. So kick off chapter 13 with lesson 13.1. And chapter 13 involves area and volume. Area and volume. And so we're going to start off with parallelograms. Parallelograms, right? We already know what they are. We're going to figure out area and such for parallelograms. Okay, what is area? Well, first off, we better understand what area is. Area is the number of square units. The number of square units needed to cover a region. Now, you can take a look at the big area right here. And you can see it's broken up into squares. And I can count every single square. All right, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. I can go quicker. Another 12, 24, 36, 48, 60. There are 60 square units in the whole area there, 60 square units, all right? What are the units? I really don't know because they don't tell us, but we know they're square units because you have a bunch of squares. And then I have a bunch of shapes in here as well, right? And this top left shape, I can figure out that it's what? 1, 2, 3, 4, 5 square units, right? The cross-looking shape below it, 1, 2, 3, 4, 5. They cover exactly the same amount of area. Now, they do it differently. If you've ever played Tetris or a game like that, obviously the shapes are a little different, but they cover the same amount of area, right? They both cover 5 square units of area. By the way, even the shape all the way to the right is 5 square units. 1, 2, 3, 4, 4.5, 5. So that's exactly the same amount of area in those 3 shapes. How about this one? Well, you're going to have to come up with a special formula for that one. All right. That one's going to take a little bit more interesting aspects to it. And we could figure that one out, but not right now. All right. What are the units for area? Well, they are square units. So they're going to be inches squared, right? A little 2 exponent. Or feet squared, which that reminds me, I've always had kids try to do this. You can no longer use that notation for inches and try to put a 2 above it. Okay, that doesn't work. That's no good. Neither can you do the 1 for the foot and put the 2 above it, right? You can't use those. You got to do IN squared or FT squared. Of course, meters squared. Kilometers squared, centimeters squared, yards squared, and whatever else you can think of. Furlongs squared, whatever unit of measure can be squared, any unit of length. Okay, next thought here. Obviously, you can see this shape is comprised of square units, and they are inch by inch squares, right? It's pretty easy to figure out. There's 1, 2, 3, 4, 5, 6. So we have 6 inches squared or square inches. You can say it either way. 6 inches squared or 6 square inches of area, right? That is the area that it takes up. Area is how much space something takes up. And that takes up 6 squares of an inch by inch. Okay? 6 square inches. Let's get into our shapes here. So number 2, let me get this a little higher for you. So area of a parallelogram. And off to the right, I have a parallelogram right here. And so I'm going to use my red here. The formula for area of parallelogram is pretty simplistic. A lowercase b for the base times, and I'm going to take my green and use an h for the height. The area of a parallelogram is base times the height. So if you look at the parallelogram to the right, this we'll consider the base. Now, quite honestly, this side could also be the base, if not that one. Or maybe you want to make it that one. Or maybe you want to make it that one. In reality, any of the 4 sides can be the base. It doesn't have to be, quote unquote, the side it's sitting on. Although we always want to think of it that way, it doesn't have to be. All right, for our purposes, this first one, we'll consider that the base. Now, it's important that you understand the relationship between the base and the height. If you'll get the relationship correct, you'll do well in these. They're easy. So the only thing you can mess up is figuring out what side is the base and what is the height. All right, so A here, the height, notice the color coding, H, is the, and this is the key, perpendicular. Perpendicular. Hopefully you remember from last chapter that perpendicular lines are lines that meet at a 90-degree angle or a right angle. So the height is always the perpendicular distance between what? Between the base and its opposite side. So look back at our illustration. Here's the base, here's the opposite side. So our height must be perpendicular to the base and go to the opposite side. And by the way, it's perpendicular both ways. Either way you want to look at it, usually we only put one right angle symbol there. Okay? And let's put an H there for the height. Now, notice this aspect. All right, let me go back. Let me see if I can get just this line segment. Oh, good. Okay, look. Do you see how it doesn't matter where it's located? It's still the same distance. Look how it doesn't matter where it's located. Watch this. It can even be out here. If we put it out there, usually we'll do a dotted line, and we'll usually put the right angle there. So the more normal thing when it's outside is to have it on the other side. Watch, let me show you. And to have it like over here. Isn't that still the same distance, right? And usually we'll put a dotted line here. See how it's perpendicular, and it is exactly the distance between those two sides, right? I mean, yes, it is. Because remember, where did it come from? It came from here to begin with, right? That's where it was, right there. Okay, so the height. So if you look at our illustration here, again, I can put a height anywhere along here. I can stick one here. Second example, I'm going to go outside. Got to extend the base, right? The line with a imaginary line, so we see where the height is. Now be careful on this third one. We've got to be perpendicular to this side. So again, remember, you can take your protractor and draw a 90-degree angle there. I think it's going to be about something like that. Does that look like a 90-degree angle? And that would be our height, okay? Because this is our base, this is its opposite side, and the height has to be perpendicular to both, okay? So if ever, anything's going to be tricky, it's just that. Other than that, these are pretty simplistic. Okay, next page. All right, so we have our first area problem. So we want to find the area of the shape. So here's how you would normally do a problem like this. First off, you would think through and say, what kind of shape is this? And hopefully you would say to yourself, this is a parallelogram. All right. I always put the little subscript in, area of a parallelogram. Now look, you say, nah, I don't want to do that. That's like a little extra. I don't want to do that. Okay, good. Now your mind has to keep straight between, listen now, here's what we're going to learn in this chapter. Area of a parallelogram, area of a rectangle, area of a square, area of a circle, area of a rhombus, area of a trapezoid, area of a circle. Got it? And there are others. Later on in geometry, you'll learn the area of a polygon, etc. So, hey, you got to keep them straight, and your brain's got to keep them straight. Use the subscripts. It'll help your brain keep them straight. The formula is easy. Again, we already know it. It's base times height, but use the subscript. It'll help you out. Okay, well, this one, I always start with my height. The 8 inches has to be the height. Once that's determined, my 10 has to be the base. Okay. Once I write para one time, I don't write it again. Again, what's my base? 10. And notice, I've told you guys this before, I always include my units, 10 inches. What's my height? 8 inches. And again, I include my units. So where do we end up? 10 times 8 is 80. What's inches times inches? Inches squared. And the area of our parallelogram is 80 inches squared. All right, second problem here. So same situation, we've got a parallelogram, area of a para equals base times height. Go ahead and write your formula in. All right, why don't you pause the video, see if you can figure out the area. All right, just pause it, because if you don't pause it, I'm going to keep going, and you really need to practice. All right? All right, if you're back, hopefully you thought through this. This is the height, right? It's the only thing that's perpendicular to two sides. This has to be the height. Therefore, this 7 inches has to be the base. And I hope you use the right numbers. So the area is going to be the base, 7 inches, times the height, 10 inches, and this area is 70 inches squared. 70 square inches, 70 inches squared. Okay? Again, remember, that height is perpendicular, and I'll just show you. Again, I can take that and move it, and you'll see how it's the perpendicular distance between the base and its opposite side. And opposite sides of a parallelogram, by the way, are always the exact same value. Opposite sides of a parallelogram, always the exact same value. Okay, let's go on, move on to area of a rectangle. Now, a rectangle is just a parallelogram. So would you believe the formula can be base times height? And that's what I recommend. That's easy. Same thing, right? However, elementary, we learned that area of a rectangle is length times width. If I meant that to be black, so you can use your black if you want. Length times width, right? So either way, again, I prefer base times height. And because a rectangle has all right angles, one of the sides is the base and the other side is the height. Or one of the sides is the length and the other side is the width. Now in this example, we have a little bit different scenario. We want to find the height of the rectangle. We're going to start the same way. We're going to start with our formula, area of a rectangle, RECT. All right? And I'm going to use base times height. Now it told me the total area, 154 centimeters squared. What would you put in for the base? Well, there's only one number, right? 22 centimeters. And that's going to be times the height, the value we're trying to find, right? So where I'm at, use my formula, area of a rectangle is base times height. Put in the area for the area, put in the base for the base. How would you solve this equation? Things multiplied times variable, you move by multiplying by the reciprocal, or you can use the shortcut and divide both sides by 22 centimeters, right? Look what happens on the left. Our h is isolated. By the way, look what happens to the units on the right. Centimeters squared is centimeters times centimeters. What's a centimeter divided by a centimeter? No different than a 5 divided by a 5, then a 3 divided by a 3, then a 7 divided by 7. They divide out into 1. And we're going to end up with 154 divided by 22. Just punch that in your calculator, right? Going to take your calculator, 154 divided by 22. You should end up with 7. And what are our units? Centimeters. And I didn't forget them because I kept them in the problem. All right, 7 centimeters is my height. All right, next one's easy, area of a square. Again, we have two formulas. Because a square is a parallelogram, guess what one of its formulas are? Base times height. But because all the sides of a square are the same value, you can just simply do sides squared. Base times height or side squared. Now, for a square, any side can be considered the base, and any side adjacent to it, right next to it, can be considered the height. But squares are pretty easy. So the only time they're a little interesting is when you're asked a problem like this. Find the length of a side of a square if the area, oh, they gave us the area. So how would you do a problem like this? Start with the formula, right? Area of a square equals, and now I have to decide, do I want to use base times height or do I want to use side squared? Well, I'm looking for a side, so I'm going to use side squared. Does that make sense? I can use either one. And it is wise to know both. Gives you more flexibility. So area of the square equals side squared. All right, substitute. Where our area is, put 289 inches squared. I keep doing inches today. I don't know why. 289 inches squared. And on the right-hand side, put side squared. Uh-oh. Remember how to do exponential equations? We're supposed to isolate the squared term. Hey, isn't it isolated already? Do you remember what to do to both sides? You're supposed to take the square root of the right side to get to s, and whatever you do to one side, do the same thing to the other side. So the square root of s squared is s, right? Do you remember how square roots undo squares? And the result is the radicand? We talked about that a couple chapters ago, right? And then take your calculator. What's 289? Hit the square root button, and your calculator is going to calculate the square root of 289. It's going to tell you 17. And I feel a sneeze coming. Sorry. Oh, boy. Nope. Always whenever I say I feel like I'm going to sneeze, it stops. So it did. All right, here we go. The other thing is your units. Remember, square roots, undo squares, right? And what's left? The radicand. 17 inches is the length of the side. 17 inches. All right, that's the only way we can make a problem like this even a little bit challenging. Other than that, they're pretty simplistic if it's a square. But now we've got a little bit different scenario, an irregular shape. So to find the area of irregular shapes, the concept is to divide it into, and I say rectangle, squares, or parallelograms, but divide it in the shapes that you can find the area of them. Right now, we've only learned rectangles, squares, and parallelograms. Later on, we can divide it into circular areas or triangular areas or stuff once we learn those formulas. But right now, we're going to divide it into areas that are rectangles or parallelograms. And I can see I got to move this a little bit here. Okay, so if we look at this, there's a couple different ways you can divide it. You can divide it here. Don't do this yet. Right? And that gives you a top rectangle and a bottom rectangle. Or I like this division a little bit better. It doesn't really matter. Either way, we'll give you the same answer right there. All right, now when I do this, I like to name my areas. This is area 1, right? A little subscript 1. And to the right is area 2. And here's your main formula. Don't miss this. Would you agree that the total area total, equals area 1 plus area 2? Does that make sense? Right? Look at the shape. Don't we have to figure out how much area we have here and how much area we have here and add the two together? Hope that makes sense. That's exactly what we've got to do. All right, so usually I just use A of t after that. All right, what kind of shape is area 1? Either a rectangle or a parallelogram, so that's a base times height. And what kind of shape is shape 2? So that's also a base times height. Now, sometimes students prefer you do like base of area 1, height of area 1, base of area 2, height of area 2. That's not a bad idea, just to keep things straight. Because you have more than one base and more than one height. Does that make sense? All right, so let me pause. Right? So let's look at the shape. Would you agree this 6 would be called base what? Base 1, right? And it is the 9 that is height 1, right? Now look at area 2. Uh-oh, we don't know what value base 2 is. But remember we had a problem like this the other day where we can figure it out? So do you know what the length is of base for area 2? Well, hopefully you said that it's 8, right? It's base 2. How did I figure it was 8? Remember, it's 14 the whole way. I used up 6 going that far, so I've got to use up 8 to go the rest of the way. That's the logic on that. And we've got to figure out the height as well. We don't have a height listed for area 2 either. Well, watch. We've gone 7 this far. The whole way is 9. So what must be the height of area 2? And hopefully you'd say 2 would be the height. Okay, now it's just simple substitution. Base of area 1, 6 times height of area 1, 9 plus base of area 2, 8 times height of area 2, 2. Does that make sense? We're just doing 2 things at once. It's 2 rectangles. It's 2 problems in one. See how orderly the work is? This is how your work should look. 6 times 9 is 54. Because I don't have any units listed, I'll put units squared. 8 times 2 is 16. Because I don't have feet or inches or anything, I'll put units squared. Total them up. 54 plus 16, 64, 70 square units is the area of the shape. All right, you've probably been looking at that last problem. Thought it looked interesting. I think it does. A little bit different concept here because we have like a hole. I don't really want to start dividing this up. Here's what I want to do with this problem. I want to do area total equals the area of a parallelogram. Watch, I want to take this big parallelogram right there. Do you see it? I want to take the area of that parallelogram. Now, do I have all that area? No, I don't have all that area. I have to subtract out the area of this hole, right? Right here, I have a hole in my parallelogram. I got to subtract that out. And what kind of shape is the hole? Minus the area of the square. All right, it's easy to do. Can you finish it? Well, you just got to be careful. Where's your base and heights for your parallelogram? And where are your sides? Your sides are easy for your square. So let's go to the next step. Area of a parallelogram, base times height, minus area of a square, side squared, right? You can still use base times height. All right, this has to be the height. Therefore, like the other problem like it, this is the base. What's that value? If the left-hand side, its opposite side is 13 feet, it has to be 13 feet. Now it's just substitution. Area total equals 13 feet times a height, 21 feet, minus, what are our sides? 6 feet squared. Calculator. So our total area, take your calculator, what's 13 times 21? Hopefully you think 217 feet squared. 6 feet times 6 feet, 36 feet squared. You can finish off with your calculator. 273 minus 36, grand total 237 square feet. All right, that's the lesson. Parallelograms, figuring out area. What's area? Number of square units needed to cover a shape. And so make your work look like the example problems. You got to be orderly in these. You got to start with a formula, substitute in. Some of you sloppy people, you're going to have trouble here. Some of you people, you're kind of scattered all over the place. Get orderly and have a nice and orderly problem like that, right? Step to step to step, and it'll make it easier. All right, that's it for today. Have a great day.